want to introduce you to electric vehicle regenerative braking.
Okay.
Okay? I want to introduce you to why, well, what I'm introducing you to is generator armature reaction. Okay? That's the engineering term for regenerative braking. Okay? And I want you to physically experience what that means. Okay? So, what I want you to do, you are going to be what's called the prime mover. Okay? In this demo, this was the prime mover. Okay? In here, that was the prime mover.
Okay.
In a wind turbine, the wind is the prime mover.
That's right.
Okay? So
That's right.
what I want you to do, you're going to be the prime mover, and you're going to turn this generator. Okay? So start turning it. Doesn't have to be fast, just turn it with a steady, keep it going at a steady speed. Okay? You see it takes a certain amount of energy, you're just idling right now. Okay? So, what I'm going to do is I'm going to connect this wire, keep going,
Okay. Oh, sorry.
and current's going to flow
Okay.
through the windings, and you're going to experience generator armature reaction, EV regenerative braking. Okay? Keep going, keep.
It's done.
You see how hard it is? Okay? Now, turn that motherfucker. For real. Look how much current you're
I
producing.
know.
Nothing. You're producing no power, and look how hard it is to turn. Imagine a wind turbine that's generating 1,000,000 watts. Okay? Imagine the amount of energy going in to turn that generator. It should blow your mind, because you can see how hard it is to turn that generator when you're generating almost no power. Okay? That's why when I said you are not going to make this generator turn this motor and make it go faster while reducing the consumption of this motor while you're also generating power. You're starting to get,
Yes,
you're starting to get
yes.
the colossal magnitude. Okay?
I'm with you. I'm following.
Okay. So now we're going to do the EV. Okay? So I want you to stand right here. That's a good spot. You got them on there? Okay? So we've taken this and we put it in here. Okay? And we're using the e-bike's bike motor to drive the generator. When this EV is on the road, it's the inertia of the vehicle that drives the generator. Okay? It's not, this also is acting like a motor. Okay? And it can also, again, act like a quantum motor or a normal motor. These two motors, when it's in an EV like a Tesla, they're doing the same thing, accelerating the EV. Okay, you got that? And when the switches are on this side, this is for the generator. Okay? When the switches are on this side, that is operating as a motor. Okay? It's not connected as a motor right now, but that's how it will be in an EV. Okay? Then when the switches are on this side, it's regenerative acceleration. And I want you to, I'm showing you this because I want you to have the experience seeing what it's like in an EV. Okay? And again, there's 5 coils in there, but there could be 12 coils or 20 coils or 100 coils. This is why I said to you on the phone, it doesn't matter how many coils you have. You can have 1,000,000 coils and generating power to the battery, and the only consequence is your car is going to go faster. And it's going to recharge the battery. So, if you think you need plug-in recharging after that, that's fine, but I don't imagine,
No.
I don't think so. The Nissan Leaf requires 20 kilowatts of power to drive down the highway at 100 kilometers an hour. Okay? So we we generated a tenth of generated 120 watts here, okay? So a tenth of a kilowatt. But you can generate 20 kilowatts, 100 kilowatts and get the same effect,
Yeah.
okay? So what I'm gonna do here is I'm gonna bring this EV up to 30 kilometers an hour. It's got cruise control. Speed's gonna be set. I'm going to show you regenerative acceleration, and the difference between this one and that one, we're going to be generating almost 13 amps to the battery. Okay, there we did 6, here we're doing 13.
Okay.
Same difference. Okay, this could be 130 amps or 1,000 amps or any number. And the more, the bottom line is, the more current we send to the batteries, the faster the EV goes, okay? So, now that we have this, then we take this, and we put it in that over there,
Okay.
okay? So this is the steps, this is the steps of developing our intellectual property. Bench model. This is a roadworthy prototype. You can actually drive this on the road. I don't, but you can. I have driven it on the road. And from here, it goes into somebody who makes actual motors. Okay?
Okay.
Those are the steps.
And this bike is, again, fully EV.
This is completely electric. Yeah.
Okay.
Batteries, driving this motor,
Sure.
and this motor looks like one of those.
Sure.
Okay?
Incredible, my friend.
So this is,
Incredible.
so one more thing. This is why I said, if you want to go and start an electric car company, if that's really what you want to do, that's fine. But if you're going to start an electric car company with this technology, if you're going to start an electric car company, you're going to compete against everybody,
Yeah.
right?
Yeah.
If you start an electric car company with this in your back pocket, now you're going to rule the EV market.
Mhm.
Everybody's going to have to come to you.
Yes, sir.
The other option is to compete with everybody else on a level playing field.
Yeah.
This, you're creating your own, you're creating your playing field, which is up here, and everybody else is down here.
I appreciate the offer and I appreciate the demonstration. Thank you very much for all your.
Let's go outside and
Sure. We can talk.